An enzyme catalyzes the conversion of 30 micromole of a substrate to product at reaction velocity of 9 micromole per second. When ET is equal to 30 nanomole and Km is equal to 10 micromole, Kcat by Km of enzyme will be N into 10 to the power 7 per mole per second. The value of N here is what? So first, let's look into the Michaelis-Menten equation, which is V is equal to Vmax into S divided by Km plus S. We have been already provided these values into our question, which is V is 9 micromole per second as given here in reaction velocity, and S, which is the total number of substrate, is given here as 30 micromole. So if we substitute these values into the equation, we can solve it for Vmax. So if we write as 9 is equal to Vmax into 30 divided by 10 plus 30 and solve it for Vmax, we get our Vmax is equal to 12 micromole per second. Now, moving ahead, we have also given the value of ET. So if we solve using that equation, which is Vmax is equal to K2 into ET, K2 is here Kcat. So Vmax is equal to Kcat into ET. And then we already have this information. Vmax we have just solved as 12 micromole per second. Km is given here as 10 micromole and ET is also given here as 30 nanomole. So if we substitute the values into the equation of Vmax is equal to Kcat into ET, and then we find the Kcat, which is 400 per second. Now Kcat by Km, that value is also provided to us, however in the terms of an unknown variable n. So if we solve it on our behalf, where we both have Km value already given to us and Kcat we have just solved using the Vmax that we found out in the previous slide. So if we substitute Kcat by Km as 400 per second by 10 micromole, and then we try to bring the units into mole, so we can convert it using 1 micromole is equal to 10 to the power minus 6 nanomole. And then using this formula in mind, if we do the unit conversion and we multiply it by 10 to the power minus 6 and we solve it and then solve it for molarity, so we have found out in nanomoles. And because we did this because our values here were in nanomoles. Here if you see the Kcat value where we were trying to find out by Vmax divided by ET, our ET was in nanomole and our Vmax that we found out from the previous slide was in micromole. So we had converted this micromole into nanomole here. So we were working with nanomole as a concentration unit. So here also when we were solving with Kcat and Km, our Km was in micromole first. So we converted the micromole to nanomole first to come to the uniform standard of nanomole. And then because our answer in the question is given as 10 and into 10 to the power 7 molar, we converted the nanomole here further into molarity, molar unit by 10 to the power 5, multiplying it. So when we multiplied that, we got the value as 4 into 10 to the power 7, and that is what exactly says in the answer, that it should be something into 10 to the power 7, and we got that. The question is what is the n, so the answer therefore is 4. So to know more about enzyme and enzyme kinetics, you can refer to this course offered by NPTEL.